Welcome to video for Lecture 10, Section 1. This video introduces the reasoning for going over non-interacting and interacting first-order systems in series. In some respects, this is a review because we have mentioned before we are going over the techniques to combine different first-order processes into the overall transfer function that describes the entire process. You have seen this slide before. It is the general block diagram of a simple general closed-loop process. It shows the user set point, the controller, the actuator, process output, and sensor and the feedback element. Here again is the same general block diagram, but this time with transfer functions in the blocks. Our goal is to convert all of these elements into a single overall transfer function that describes the dynamics of the process of varying inputs, external factors, and disturbances. A single block with a single overall transfer function. The general block diagram is made up of multiple first-order process elements in series. So we need a process for combining them into this single overall transfer function. The videos for Lecture 10 will illustrate that process. We will use liquid level tanks to give a physical meaning to the process we will use by combining multiple first-order process elements in series. We will combine multiple tanks in series, and we will start in the next video with non-interacting tanks, which we will define as tanks that are independent of each other, which really means that the flow and the liquid level in upstream tanks are not dependent on flow and liquid level in the downstream tanks. We will define interacting tanks as tanks where adjacent downstream tanks do impact the flow and liquid level of upstream tanks. We will use the method to show how to find the flow rates from the tank and liquid levels within any tank in the series of tanks. Let me make the point that we are using tanks to give the process a physical meaning, but the technique will be used later for other closed-loop processes with different elements in series. This slide summarizes the key points of Lecture 10. We will use first-order differential equations to describe many practical processes. We will transform them into transfer functions that relate the process inputs to the process outputs. General closed-loop processes can be described as a series of these first-order transfer functions. After Lecture 11, you will be able to combine the multiple transfer functions into an overall transfer function. We then can solve for the output in the Laplace domain and take the inverse to find the time-dependent expression that describes the overall process. This brings us to the end of Lecture 10, Section 1.